In this video, we're going to look at multiplying and dividing numbers in polar form. So when you multiply two complex numbers in polar form, z1 and z2, and z1 is equal to r by the cos of a plus I sine a, and z2 is equal to r1 by the cos of b plus I sine b, the subsequent answer is going to be you multiply the two modulus and you add the two angles. So the angles could be theta, theta1, any version of an angle. So let's have a look at why this is the answer. So if we say or, so z1, z2, we'll multiply it out, is equal to or by cos a plus I sine a by r1 by cos a cos b plus I sine b. You can see here we multiply the r by the r1, we put them in front. We multiply cos a by cos b, and we multiply cos a by I sine b. And similarly, we multiply I sine a by cos b, and we multiply I sine a by I sine b. And you see here we have an I squared. So this is going to become a minus 1 times sine a sine b, or minus sine a sine b. So if we put the real parts together, we're going to get cos a, cos b, minus this guy, minus sine a sine b. And then we can factor out the I in these two. There's an I in this one, and we'd multiply that by cos a sine b plus sine a cos b. And these are, and from the formula booklet, cos a cos b minus sine a sine b is the cos of a plus b. And then we have plus I, and from the tables, cos a sine b plus sine a cos b is the sine of a plus b. So this is the proof of multiplication of two complex numbers in polar form. So you just multiply the modulus and add the angles. Really, really simple. So very similar, the division of complex numbers in polar form. This is the answer. Z1 over Z2 becomes the modulus divided by each other and the angles subtracted from each other. So let's have a look why. Let's let Z1 equal R1 by the cos of A plus I times the sine of A, and Z2 we let equal R2 by the cos of B plus I times the sine of B. So from our knowledge of division of complex numbers, we know that we need to get rid of the complex number on the bottom, we need to divide, multiply top and bottom by the conjugate of the bottom, which will be cos B minus I sine B. And obviously multiplying top and bottom by the same thing, we're just multiplying by 1. So multiplying the top, we're going to end up with R1 times cos A by cos B, so cos A cos B, and cos A by minus I sine B, so minus cos A sine B. And we can put the I in front, or in between, or at the end. So now we have I sine A by cos B, so plus I sine A by cos B, and then we have I by I, and it's a plus and a minus, so we have minus I squared, which is going to become plus 1. So we're going to have plus sine A sine B. And that's this one by this one. The minus I squared, as you know, is going to become plus 1. So that's the top line. The bottom line, we have our R2. Cos B by cos B is going to be cos squared B. Now, this is the difference of two squares. So you know that if we multiply cos B by I sine B and cos B by plus I sine B, they're going to cancel. So we just have two terms on the bottom. And again, it's going to be I by minus I. So minus I squared is going to become a plus 1. So plus sine squared B. And you know that cos squared A plus sine squared A from the tables is equal to 1. So this is just going to leave R2 on its own on the bottom. So we just have to simplify the top. So we're going to get R1 over R2 times, so we put the real parts together, cos A cos B plus sin A sin B. And from the tables, that's going to be cos A minus B, which is what we're looking for. Then we have minus I times, we could actually make it plus, might be easier, plus I times, so I'm going to put this one first, sin A cos B, just so it aligns with the tables. And then to get the minus for here, we're going to have a minus in the middle, and that's going to be cos A sin B. So R1 over R2, cos A cos B plus sin A sin B is going to be the cos of A minus B in the tables. Plus I times, and sin A cos B. Sin A cos B minus cos A sin B is going to be the sine of A minus B. And that's the proof of division of complex numbers in polar form. So let's just have a look at a couple of easy questions that relate to these two. So let's just do one question here with multiplication and division. So Z1 is 2 times the cos of pi over 6 plus I times the sine of pi over 6, and Z2 is 3 times the cos of pi over 3 plus I times the sine of pi over 3. So find multiplication Z1, Z2 and the division in rectangular form, and rectangular form is x plus yi or a plus bi or some version of those. So just need to know our rule. So Z1, Z2, multiply the modulus. So 2 times 3, or you could just write 6, but it's because you're going to definitely have another line of information, just show your work in each stage that you're going to do it. So then we're going to have the cos. What do we do with the angles? We add them. Pi over 6 plus pi over 3. So that's 30 plus 60, which is 90, if you want to think about it in degree form. Plus I times the sine of the same two angles added. Pi over 6 plus pi over 3. So we're dealing with 30 plus 60, which is 90 degrees. So we're looking for the cos of 90 and the sine of 90. And you should know from your unit circle knowledge, I'll just do a tiny unit circle. Here's 90 up here. It's the point 0, 1. So the cos is 0 and the sine is 1. So we're going to get 6 times the cos. We'll write it like this, pi over 2 first. We know the answer already. I sine pi over 2. So we're dealing with 6 times the cos of 90 is 0 and the sine of 90 is 1. So 1i. So the answer here is just going to be 0 plus 6i. So the division question, Z1 over Z2. So we know it's going to be the modulus divided. So 2 over 3. But the angles take it away. So pi over 6. So that's 30 minus pi over 3, which is 60. So that's going to give me minus 30 degrees. Let's just have a look at minus 30 degrees. So we're talking about, I'll just do a big one so we can fit it in. So we've 30 here, so it's the same as 330. So we're looking at the cos of 330 and the sine of 330. Now cos is positive in here and sine is negative. So the cos of 330 is the same as the cos of 30, and the cos of 30 is equal to root 3 over 2, and the sine of 30 is equal to a half. So we're dealing with minus a half here for the sine when we fill it into our question. So plus I times the sine of pi over 6 minus pi over 3. Now you could just use your calculator and get the cos and the sine of 330, but having your knowledge of the unit circle I think is always a good way to do these questions. So we're going to get 2 over 3 by the cos of minus 30 degrees, if you want to write it in degree form, plus I times the sine of minus 30 degrees, or you could write 330 degrees. It's whatever suits. There's different ways to do these questions. So we're going to get 2 over 3. We've already got the cos of minus 30 here. The same as the cos of 30, so it's by root 3 over 2 plus, well, it's going to be a minus, isn't it? So we're going to have minus a half times I. So we're going to get 2 over 3 by root 3 over 2, which is root 3 over 3 And then we're going to have minus 2 over 3 by 1 over 2, which is minus I times 1 over 3. If you want to simplify this, you could say this is going to be 1 over root 3 minus I over 3. So nice easy questions, these multiplication and division questions.